our previous videos, we introduced ourselves to Fourier series, and we talked on Fourier series with periodic function and also Fourier series of non-periodic functions, both with range of 2 pi. And now we want to talk about even and odd functions. Even and odd function. First question: what are even functions? What are odd functions? And what are their characteristics? Now, even functions are such that f of minus x is equal to f of x. Let's take, for instance, y is equal to x squared. We put y is equal to x squared, and instead of x, we now write minus x. So y will go minus x squared. So in that case, which is equals to x squared. So we can see that the f of x, okay, and the f of minus x, they are both similar. Let's look at y is equals to cos x, and instead of x here, we now change it to minus x, so y becomes minus x. And according to trigonometric identity, this y is equal to cos x. So drawing the graph of cos x, we have this. Now, one of the characteristics of even function is that they are symmetric with respect to y-axis. Now, if we emphasize on the y-axis, we can see that whatever is on the right hand side is similar to what is on the left hand side. So it is symmetric with respect to y-axis. Now let's talk about odd functions. What are odd functions? Odd functions are such that f of minus x is equals to minus f of x. Take, for instance, y is equals to x raised to power 3. And instead of writing x, we write minus x. So y is equals to minus x raised to power 3. And minus x raised to power 3 is minus x raised to power 3. So we can see that if f of x is x raised to power 3 and f of minus x is minus x raised to power 3. The same thing happens for y is equals to sine x. And y is changing the x to minus x. Y is equals to sine minus x. And with respect to this, according to trigonometry, y is equal to minus sine x. Now, if we draw the graph, sketch the graph of sine x, something like this. Now, one of the characteristics of odd function is that it is symmetric about the origin, such that what is on this side, on the right hand side, is equivalent to what is on the left hand side. Likewise, what is at the top is equivalent to what is below. So we can say that it is symmetric about the origin. Now, if we have even functions and we also have odd functions, so it fully explains the understanding that we say cos minus pi is equals to cos pi, because cos function is an even function, and sine minus pi is equals to minus sine pi because the sine function is an odd function. And now we might be asked to evaluate a Fourier series for odd functions and even functions. Now, what is the way about it? Recall that the formula for Fourier series, the general formula is f of x is equals to a naught over 2 plus summation of from n is equals to 1 to infinity of an cos nx plus bn sine nx. Now let's start with even function. Okay, or before we start with even function, what are the formulas for the terms? What is a naught, what is an, and what is bn? Now these formulas are related to what we call half range series. So even function might be Fourier series for even function can be further called Fourier cosine series, and the Fourier series for odd function can be called Fourier sine series, which we will look at in our upcoming videos. Now, where a naught in this case is 2 over pi integral of 0 to pi f of x dx, which can be rewritten as 1 over pi integral of minus pi to pi f of x dx, depends on which limit we are given, and an is 2 over pi integral of 0 to pi f of x cos nx dx, which is also equals to 1 over pi integral of minus pi to pi f of x cos nx dx, and bn is 2 over pi integral of 0 to pi of f of x sine nx dx, which is also equal to 1 over pi integral of minus pi to pi f of x sine nx dx. Now this set of formula is applicable to Fourier series for even function, which you call Fourier cosine series. Is also applicable to Fourier sine series, and also applicable for half range Fourier series. And now, having understood this, what is the difference between Fourier cosine series and Fourier sine series? Fourier cosine series and Fourier sine series. Now, in Fourier cosine series is such that since it's an even function and only cosine is available, we say that bn is equal to 0. And for Fourier sine series, a naught is equal to 0 and an is also equals to 0. okay, because this is related or similar to even functions, and this is similar to odd functions. Having established that, if from our formula we remember that f of x of Fourier series is a naught over 2 plus summation of n is equals to 1 to infinity of an cos nx plus bn sin nx. Now if bn is equals to 0, everything here turns to 0. So our formula for Fourier cosine series is f of x is equals to a naught over 2 plus summation from n is equals to 1 to infinity of an cos nx. Now for Fourier sine series, we repeat the same thing by writing the general formula for Fourier series. And in sine series, the odd function has only sine terms only sine terms. So a naught is 0 and an is 0. So this is 0 and this is 0. So we are left with summation from n is equals to 1 to infinity of bn sine nx. Now in our next video, we will be differentiating between, we have questions, we solve questions on Fourier sine and we solve questions on Fourier cosine.